This is lesson 59 on Arithmetic Logic Unit, or ALU. Here's the diagram for what's called an Arithmetic Logic Unit, or ALU. This is a very useful device which appears in all computers and microprocessors. It's sort of the heart of how you do calculation and logic operations. Here is the functions of this ALU. In general, we'll have any number of functions. We've chosen 8 here. So we'll have ALU select, sort of like a multiplexer select 2 down to 0. And depending upon what this ALU select is, we'll have a different function. There are 2 inputs A and B, each 4 bits in this example, and an output Y. Now, if the ALU select is 0, we'll just pass A through. So Y just gets whatever A is. If we make ALU select 1, then we'll add A plus B. We'll get an addition. So it acts as an adder then. If we make the ALU select line 2, then we'll do a subtraction, in this case A minus B. If you make it 3, we'll do the other subtraction, B minus A. So you can pick any kinds of functions you want here. The ALU select will select different operations. So it changes this ALU from an adder to a subtractor. We could do some logic functions. If we make ALU select 1, 0, 0, then it just inverts A. That is, it does a bitwise NOT operation, or 1's complement of A. If you make ALU select 5, then it does a bitwise AND. That is, each bit of A gets ANDed with each bit of B, and the result is what's in Y. If the ALU select is 6, it does an OR operation. That is, a bitwise OR. Each bit of A is ORed with each bit of B. And finally, if we make ALU select 7, it does an exclusive OR, bitwise exclusive OR. Each bit of A is exclusive ORed with each bit of B, and the result's in Y. So these are the 8 operations for this ALU. In addition, we bring out 4 lines called the negative flag, the 0 flag, the overflow flag, and the carry flag. The overflow flag and the carry flag you're familiar with. We talked about that when we talked about addition and subtraction. The negative flag will get set if the most significant bit is 1. That is, if the output Y is a 2's complement negative number. So if Y sub n minus 1 is equal to 1, we set the negative flag. That tells that the result was negative. The 0 flag gets set to 1 if the result is 0. So if Y turns out to be 0, then the 0 flag will get set. These negative flags and 0 flags, as well as the carry and overflow flags, are useful for doing branching instructions in microprocessors. So the ALU then is a general operation for doing arithmetic and logic operations. And in the next lesson we'll see how to implement this ALU on your FPGA.